Imagine being a caveman with no clock, no phone, no watch, no wall clock, only sky, only sun, only shadows, only instinct. Morning means light, night means danger. People still needed time. Time for hunting, time for gathering, time for sleeping, time for meeting, time for travel, time for rituals, time for survival. But how could they know it? That is where our story begins. At first, humans watched the sun rises, the sun climbs, the sun falls, the sky becomes a schedule. Bright morning, high noon, long evening shadows, dark night. The sun became the first guide, but sunlight has a problem. Clouds hide it, storms hide it, night erases it. People needed something better, so they watched shadows too. A standing stick creates a shadow. The shadow moves slowly. The shadow changes length. The pattern repeats each day. That was a huge clue. Put a stick in the ground. Watch the shadow. Morning shadow is long, noon shadow is short, evening shadow is long again. Now the ground becomes useful. You can mark the shadow. One line here, another line there. Now time looks visible. This idea grows smarter. The stick becomes deliberate. The marks become planned. The shadow becomes information. This is the basic idea of a sundial. Not a machine yet, but a real time tool. Simple, clever, powerful. Ancient people improved it. The dial gets shaped. The pointer gets fixed. The sun does the work. Ancient Egypt used shadow devices. Ancient Mesopotamia tracked the sun too. Many cultures study daylight. They all face the same question. What time is it? Sundials answered part of it. They worked outside. They worked in sunlight. They worked by day, but not indoors, not underground, not in heavy clouds, and never at night. So humans kept searching. Now look at water. Water flows, water drips. Water can be counted. That changes everything. If water leaves slowly, it marks duration. If water fills a vessel, it marks duration too. Now time can move indoors, and even at night. This becomes the water clock, also called the clepsydra, one container, a small hole, a slow drip. Time measured by flow. The level falls or rises. Marks show progress. Now minutes feel physical. Water clocks appear in many places. Egypt knew them. Greece knew them. Rome knew them. China knew them. Water made time portable. Well, almost portable. It still had problems. Water speed could change. Cold could slow it. Bad design could ruin it. It needed care. But it was a breakthrough. Now time did not need sunlight. That was huge. Courts could use it. Temples could use it. Scholars could use it. Night workers could use it. Then another idea appeared. Fire. Fire also changes steadily. A candle burns down. Wax disappears predictably. Marks can be added. Now the candle measures time. One mark melts away. Then another. This becomes a candle clock. Simple flame. Simple marks. Simple timing. Useful at night. Useful indoors, but fire has problems too. Wind changes it. Wax quality changes it. Room conditions change it. Nothing is perfect yet. Then there was oil. Lamps burned fuel. Fuel level could help measure time. Not always precisely, but still useful. Humans kept experimenting. Then sand entered the story. Sand flows like water, but cleaner and easier to contain. Put sand in glass, narrow the middle, turn it over. Now grains fall steadily. This is the hourglass, also called the sand glass. It measures duration well, not the time of day. That distinction matters. A sundial tells daytime position. An hourglass counts a fixed period. One helps schedule, the other helps count. Sailors loved hourglasses. Churches used them too. Cooks could use them. Workers could use them. Priests could use them. Timekeeping becomes more practical, but people still wanted more. They wanted constant time, more accurate time, more public time, not just personal tools. Now we enter the age of gear, of weights, of mechanics. This changes history. Early mechanical clocks appear in medieval Europe. At first they are large, heavy, complicated, and impressive. They are not wristwatches, they are towers. Inside them are gears. Inside them are wheels. Inside them are escapements. That is the secret word, escapement. It releases motion in steps, not all at once. That makes steady ticking possible. Now falling weights can drive time. A weight drops slowly. Gears turn carefully. The The mechanism advances step by step. This is revolutionary because now time is automated. No sun needed, no water drip needed, no flame needed. The machine keeps going as long as power continues. Early clock towers appear in towns. People hear bells. They do not need to see the mechanism. The bell tells the hour. Public time is born. That changes daily life. Workers hear bells. Merchants hear bells. Monks hear bells. Cities hear bells. Now whole communities share time. That is powerful. Medieval monasteries helped drive demand. Prayer had schedules, many schedules, regular schedules. They needed reliable timing. Clocks helped organize devotion and work and city life. At first, clock faces were simple, sometimes no faces at all, only bells. Sound was enough. Later, hands appear, then dials improve. Time becomes visual again, but now mechanical. Early clocks were expensive. They needed skilled makers. Clockmakers became specialists. Metalwork mattered. Precision mattered. Design mattered. Small mistakes ruined accuracy, so clocks improved slowly. Centuries of improvement followed. Springs changed everything again. A clock no longer needed huge weights. Now mechanisms could shrink. Portable clocks appear, then table clocks, then domestic clocks, then pocket watches. Now time enters your clothing. Rich people carry time. Status meets technology. Accuracy keeps improving. Pendulums arrive later, and accuracy jumps. A swinging pendulum is regular. Very regular. That helps clocks stay precise. Now seconds matter more. Science benefits, navigation benefits, trade benefits. Daily life changes again. Factories will later depend on clock time. Schools too, trains too. Modern life becomes clock driven. But remember the beginning. A caveman had sunlight. A city now has machinery. That journey took thousands of years. No single inventor did it alone. That is important. The first clock was not one moment. It was a chain of ideas. Sun, shadow, water, fire, sand. Gears, weights, escapements, springs, pendulums. Each step solved a problem. Daylight problem, night problem, accuracy problem, portability problem, public schedule problem. Human life kept pushing the invention. People always needed structure. They needed rhythm. They needed coordination. They needed shared time. That pressure built clocks. Now picture the first true clockmaker. Hands black with metal dust. Gears on the table. Bell tower nearby. A machine learning to tick. That sound mattered. Tick, tick, tick. Humanity had trapped time, not perfectly, but brilliantly. Then clocks spread everywhere. On towers, in churches, in homes, in pockets, on wrists, on walls, on phones, everywhere. Now we barely notice them, but once, time had no face, no hands, no ticking, only the sky. The first clock changed that forever, from cavemen watching sunlight, to cities ruled by bells, to tiny machines in your hand, and humans kept refining time. That is how the first clock was invented,